Good morning. Today we will be discussing about solutions of simultaneous equations. And particularly for this topic, we will be discussing about Gaussian elimination method or the Gauss reduction method, the Gauss-Jordan method, the matrix inversion, and the Gauss-Seidel method. But before we go to those topics, let's first review something about matrices. So on these slides, we have here properties of matrix. First, the number of rows may or may not be equal to the number of columns. So here, our M denotes our rows and N denotes our columns. So according to property number 1, it may be equal or it may not be equal to the rows may not be equal to the number of columns. Number 2, matrices or the elements in the matrices or matrices is just a collection of elements and has no single value. So we have different types of matrices. First, we have the row matrix. So as you can see in the example, in a row matrix, the elements are arranged in a row. In a column matrix, the elements are arranged in a column. There is only one column and the elements are arranged in a column manner. Now we have the square matrix. When we say square matrix, we have here, as you can see, the number of rows is equal to the number of columns. So if there are 4 elements in a row, there should also be 4 elements in a column. If there are 5 elements in a row, there should be also 5 elements in a column. Next, we have the null or zero matrix. So null or zero matrix is a matrix whose elements are all 0. So regardless of the size of the matrix, the elements or all of the elements are 0. We also have the diagonal matrix. So in a diagonal matrix, there are only values in the matrix, or the values in the diagonal, or there are only values in the diagonal of the matrix, and all the rest of the elements are 0. As you can see, the upper triangular elements here are 0 and the lower triangular elements here are also 0. There are only values on this diagonal. And then we also have the identity or unity matrix. When we say unity or 1, so the value of the diagonal are all 1. And as you can see, the value of the lower triangular elements are also 0. The value of the upper triangular elements all are 0. Number 7 is the upper diagonal or upper triangular matrix. So as you can see in the example, only the upper triangular matrix has the values, while the elements in the lower portion of the diagonal is all or are all 0. Then we have the lower diagonal or lower triangular matrix. So in this type of matrix, only the lower triangular elements has the value of the matrix, while the upper elements are all 0, or the elements above the diagonal are 0. So we also have here the properties of the matrix. First, we have the equality of the matrix. Two matrices are equal if and only if they are identical. That means the elements in matrix A is equal to matrix B only if and only if the arrangement of the elements in matrix A is the same as the value or the arrangement of the elements in matrix B. Then we have the addition and subtraction of matrices. So matrices must have equal size in order to be added or subtracted. So we add or subtract elements of the same position. Like for example, if this is our matrix A and this is our matrix B, if we are to add matrix A and matrix B, we are to add or subtract elements of the same position. So 3 plus 2 in addition of matrix, that is 5. 4 plus 6 is 10. We have negative 7 plus 1, that is negative 6. And 1 plus negative 3, that is negative 2. It also follows the same on the subtraction of matrix. Next is the matrix multiplication. We have this scalar multiplication. So on this example, we have here matrix A, and if we are to multiply a scalar value, say for example, in this case, we multiplied 2 to matrix A, it just follows that all elements in the matrix is multiplied by 2. So that becomes 2 times 3 becomes 6, times 4 it becomes 8, negative 7 times 2, negative 14, and 1 times 2 it becomes 2. So multiplication of matrix. So in this example, we are to multiply this is 2 by 2 matrix, and this one is a 2 by 3 matrix. Sorry for the penmanship. Then we can only multiply matrices if here the inner values are the same. And of course, we know that the resulting matrix, the size of the resulting matrix is equal to this outer value. So it is expected that when we multiply a 2 by 2 matrix and the 2 by 3 matrix, the resulting matrix should be 2 by 3. Because as we have said here, the rule in the multiplication of matrix is that one. So how do we multiply the matrix? Of course, it is the elements in the resulting matrix is equal to the sum of the products, or the products of the multiplied elements in the row and the multiplied elements in a column. So for example, here we have 2 times negative 1, that is negative 2, and we have 3 times 2, that is 6. That will be the answer in the first element. Then we have here 2 times 0, that is 0. We have 3 times 4, that is 12. Then we will do the same with this one. 2 times negative 2 is negative 4, and 3 times 3 is 9. We do the same on the lower values, and the resulting product is this one. So let's now go to our first topic. Our first topic is on Gauss reduction or Gaussian elimination method. So in this method, the principle is to reduce or convert the augmented matrix. When we say augmented matrix, it is a matrix formed by placing side by side two or more matrices. So augment the matrix of coefficient with the vector of the constants. So that's what we will be doing, into an upper diagonal matrix or unity matrix by row transformation. So here, this is an augmented matrix. So for example, these are the elements in the matrix, and we will augment it by the value of the constants. So in Gaussian elimination, we set the major diagonal to 1 and the lower elements to 0. So we will be resulting in a diagonal matrix, or as we discussed previously, we have only the upper triangular matrix with the value, and the lower triangular elements will be 0. So that is our target in solving using Gaussian elimination method. So we need to zero in the lower elements of our matrix. So to fully understand the Gaussian reduction or the Gaussian elimination method, we have here the example. So this is a 4 equations for unknowns. So we have here 3a plus b plus c plus d equals -4. So that is -3a plus b plus 2c minus d equals 14. We have 2a minus 2b plus 3c plus d equals 10. 5a plus b plus 2c minus d 2d equals 22. Actually, what we have done here is we place the unknowns in a table form, and we took the constants as a matrix. So this one will be our first matrix, this one will be our matrix, and this one will be our augmented matrix. So this is our augmented matrix. So here we are given the steps. So the first step is to set the first diagonal element to 1. So it is said that our first target is to make this element, this 3, into 1. Or we must make this first diagonal element. So what is the diagonal of this matrix? What is the diagonal of that matrix? So this is the diagonal of this matrix. And our target is to make these diagonals here, the first target is to set the first diagonal element into 1. So that is, we will make this diagonal element 3 into 1. So how do we make 3 into 1? So we have here, in order to make this 3 into 1, we will divide it by itself. or that is R1 equals R1 divided by E11. So for the rest of the discussion, when we say E11, this refers to the element in row 1 and this one refers to the element in column 1. So E means element, E subscript 1, the first digit is the row, the second digit will be for the column. So here, row 1, or we will get the values of all the elements in the row using this formula. R1 is equal to R1 divided by the element in the first row, first column. So in order to make this element 3 into 1, we will use this formula, or we will divide it by itself, or R1 divided by the element in the first row, first column. So we will apply it to all the elements in the row in order not to alter the value of the equation. So applying the formula to all the elements in the row, we have 3 divided by 3 because 3 is the element in row 1 divided by the element in row 1, column 1. That is also 3. So 3 divided by 3, that gives us 1. 1, here, we are now here, because as we said, we will apply this formula to all the elements in the row in order not to alter the equation. So we are now on this second element in the row. So 1 divided by, that is the element in row 1, divided by, take note that E11 here is constant. 1 divided by 3, that gives us 1/3 or 0.3333. Then we will apply it here. 2 divided by 3, that is 0.6667 or 2/3. We have 4 divided by 3, that will give us 1.333. And of course, the constant 4 divided by negative 4 divided by 3, that gives us 1.333. So that gives us this matrix here. So that is the first step. To make the first element in the diagonal as 1. Now, the second step will be to zero, or to make all the lower triangular elements in column A. That means after obtaining 1 here, we need to make all the elements below 1 to be 0. That means all the elements below 1 should be equal to 0. And how do we do that? So in order to make this element into 0, of course, we are to subtract the elements with the same value as the element. So that's why we have arrived to this formula. So we need to make this 1 in order to that, for us, it is in order for easy subtraction, because if this one will be 1 and if we have 3, in the formula, if you can see, R2 minus E21 times R1. So the element in R1, if this is 1, it will be easier for us to make this element 0, because we will be thinking only of the value that if this is 3, negative 3, if you subtract it to 3, it will be 0. If this is 2, you have to subtract it to 2, it will be 0. This is 5, if you subtract it to 5, it will be 0. So that is one purpose of making this element as 1. So back here, our step number 2 is to zero the lower triangular elements in column A. So if you have noticed, this is column A. Below 1, we need to make these elements into 0. So take note here in our discussion that our purpose in Gaussian reduction or in Gaussian elimination method is to make all the elements here as 0, so that the remaining will be only the upper triangular elements of the matrix. So we need to make these elements here 0, or we make these elements here 0. And how do we make these elements into 0? So we have here the formula. It will be R2, or the new R2, or the new value here will be equal to R2, this here, value, minus itself times the value of the element in row 1. As you can see, negative 3 minus itself times the elements in row 1. So as I have discussed with you earlier, we made this 1 so that it will be easier for us. So we will not make ourselves dizzy with looking for values that will make this thing into 0 if this is 1. So for simplicity of our discussion, say in the formula, so we have R2 is equal to the element in row 2, column 1 times the value of the element in row 1. When we say the value of element in row 1, it is the value of the element directly above or in row 1 where the element that you are computing is located. See, for example, what is the value of the element in the second row, first column, if this is our general formula? So as we said, the element in the second row, first column will be, we will follow this general formula, row 2, that is negative 3 minus, we have here the element in the second row, first column, that is also minus 3 times the element in row 1. What is the element in row 1? That is the element directly above negative 3. So that is 1. So that is equal to negative 3 minus negative 3, that becomes negative 3 plus 3. The answer here is 0. So that's why our first element here in the second row, first column is 0. Then we will apply the same to all the elements in the row because we are doing the row transformation. This one will become the elements in the second row, second column is equal to, that will be 1 minus, so take note that E21 here is constant or is fixed. That will become minus 3 times what is the element directly above 1, that is 0.3333. So this is 1 minus negative 3 times 0.333, that is approximately 1. So 1 minus negative 1, that gives us 2. Then for the elements in row 3, that is this element in row 3, that is 2 minus, we have here minus 3 times 0.66667. Oh, forgot, this one is equal to 2. So negative 2 minus negative 3 times 0.6667, that will give us how much? 2. 4. This is equal to 4. And R4, which is equal to R4 is equal to here negative 2 minus negative 3 times 1.3333. I think that will give us how much? It will be negative 2 minus, I think this is 4, so that will give us 2, positive 2. This one is 2, and for the last element, R25 is equal to 14 minus negative 3 times negative 1.3333, that will give you 10. So the value of the element here is 10. So that is how we got these values here. So you will be doing the same for the elements in R3 and R4. So take note that here we are still multiplying in or to the values of row 1. So here we have here 2 minus elements in the third row first column times R1. So it will be 2 minus 2 times 1, so it becomes 0. We have negative 2 minus element in the third row, first column, 2 times R1. So can we do that in the other sheet here? So we will try here. So what will be our element in R3? So we have 2 here, 2 minus, we have here 2 times 1 equals 0. Our first element here will be 0. Then we have here R32 will be equal to, this is the value of the element in row 3, second column, that is negative 2. So minus 2 minus constant is 2, and the element in row 1, which is 0.3333. That is equal to how much? Negative 2.6667. Negative 2.66667. So we have R34 equals, what is the value of the element in R3? What here we have here 3. So we have here 3 minus constant, the 2 is the element in the third row, first column, times the element in third row. We have 0.66667 is equal to, how much is the value? 1.6667. 1.66667. So we have here minus 2.66667. We have here 1.66667. Oh, we are only on R33. This is R33. Then we have R34 is equal to, what is the value of the element in row 3, fourth column? So that is 4 minus, we have here 2 times 1.3333, that is equal to how much? 1.33333, 1.33333. And of course, R35 equals, what is the value of the constant here? 10. That is 10 minus 2 times, what's the value of constant? Negative 1 negative 1.33333 is equal to 12.667. So that is how we got these values here. And you will do the same with the rows in row 4. The third steps after zeroing in all the elements in the first column is again to make the elements here. So again, our target is to make the diagonal into 1 or into a unity matrix. So we need to convert or to make the elements here into 1. So this has been the result. This has been the result of resulting matrix after we have performed all the zeroing in of the elements in the first column. So our next step is to make this element here into 1. Because again, our target is to make the diagonal 1. So how do we make this 2 into 1? Of course, again, by dividing itself by its value. So R2 is equal to R2 divided by the element in the second row, second column. So take note here that the element that we are dividing is already on the second row, second column, because our target is to make this element in the second row, second column into 1. So that is the row 2, all the elements in the row 2 shall be divided using this formula, or shall be converted using this formula. So that means, so 0 divided by 2 is of course 0. 2 divided by 2 is equal to 1. 4 divided by 2 is equal to 2. 2 divided by 2 is 1. And 10 divided by 2 is 5. And then we just copy all the remaining elements here at the bottom. So that's how we got here to this table. Then the next step is, after making this element as 1, we again need to zero in the lower triangular elements in column B. So in order to make these elements here into 0, we will apply the formula row 3 is equal to the values of row 3 minus the element in the third row, second column. This is the third row, second column, times the value of R2. So take note that we are not doing anything about this first row anymore. So the values of the third row, or the new values of third row, will follow this formula. R3 is equal to R3 minus the element in the third row, second column, elements in the third row, second column, times the value of R2. So that will give us this value. So the next After zeroing in this one, again, the next step is to make this element here into 1. We need to make this third diagonal element into 1 because again our target to make the diagonal element into 1. So we have to divide 7 by 7 in order to make it 1. However, we will also apply the formula to all the elements in the row. So that's why in step number 5, we are here to set the third diagonal element to 1. The formula will be R3 divided by the element in the third row, third column, which is 7. So 7 divided by 7, that will give us 1. So 0 divided by 7 is 0, 0 divided by 7 is 0, 7 divided by 7 is 1, 4 divided by 7, that is 0.571429, and 26 divided by 7, that will give you 3.714286. Then you copy the lower element. Step 6 is supposedly we are to make the element below 1 here in the third column into 0. But fortunately, in our example, it is already 0. And of course, the last step is to set the fourth diagonal element into 1, because our target is, again, we make these diagonal elements into 1. So we have 8. In order to make this as 1, we divide 8 by itself, or negative 8 by negative 8. So you have here the formula R4 is equal to R4 divided by the element in row 4, column 4. The element in row 4, column 4 is negative 8. And then you apply that also to 32. So positive 32 divided by negative 8, it will give you negative 4. So now we have achieved our target, making all the diagonal elements into 1 and making all the elements in the lower triangular parts of the matrix as 0. So in order to solve for the values of the roots or the values of the unknowns, we have here the unknowns A, B, C, and D, we will be applying the reverse substitution or the back substitution method. So take note here that this one corresponds to the value of D, this one C, or if we will translate it to its equational form, this one gives the value of D. So that's why here D equals negative 4. Now since we have already here the value of D, we can substitute the value of D to this equation. So what will be this equation? As you can see, the equation is 1C plus 0.5714D is equal to, since this is the constant, 3.714286. So that is this equation. But we already have the value of D here. So we substitute the value of D, then we get the value of C. We do the same, we have the value of C, we have the value of D, substitute it to this equation and we get the value of B. In this case, B is equal to negative 3. And if we have the three values of B, C, and D, we can now get the value of A in this equation. Substituting the values, we get A is equal to 1. So for our final answers, the value of the variables are A equals 1, B equals -3, C equals 6, and D is equal to -4. You can check your values or your answer if they are correct by substituting the values taken or the values derived to any of the equation in the original equation. So you can check the values derived if you can you can substitute it to this equation. We have 3a plus b plus 2c plus 4d is it equal to -4 if you substitute the values of the derived equation. If it is correct, if it is equal to -4, then our answer is correct. So that is all for Gaussian elimination method or the Gauss reduction method. See you next for the next topic, Gauss-Jordan method.